Hey everybody, what's up? Mr. Murray here, Mr. Murray's Mathland, and today we're talking about taking the derivative of natural log of x and other natural log kinds of functions. So let's just, we'll get the rule right out of the way here. And it's actually a pretty easy one to derive, but you can find a million videos that do that, I'm sure. The derivative of ln of x, natural log of x, is 1 over x. And so that's a pretty straightforward, simple rule, but like a lot of things in calculus, you'll have to watch out for the chain rule. So if it's not just ln of x, if there's some other sort of quantity there, and we'll represent that with u, then the derivative is going to be 1 over whatever that u is, but then you have to multiply by that quantity's derivative. So we'll just say u prime, and so you'll often see the rule just expressed this way as u prime over u. And a lot of kids will go right to that, but however you like to think about it. So let's just dive in and do a few examples here. Number one, start off pretty simple here. Y equals ln of x to the 7th. So we could jump right in and start differentiating and say y prime therefore is equal to 1 over that argument of x to the 7th, and then multiply by that argument's derivative. And the derivative of x to the 7th is 7x to the 6th. And what you're going to find is that, of course, that will reduce that x to the 6th will cancel with all but one of those x's in the denominator, and we'll have 7 over x when all is said and done. And there we go. But another nice thing to notice is that your properties that you learned about logs in pre-calc in Algebra 2 still hold, and sometimes make your derivatives easier. So let's just look at this. If you were thinking of using that power property, which is that you can take that exponent of 7 and pull it out to the front, and this is before doing any derivatives, that's just using a little Algebra 2 pre-calc maneuver there, that could be thought of as 7 ln of x. Now when you do that derivative, you'll just have 7 times the derivative of ln of x, which is 1 over x. And so you get the same 7 over x that we got the first way. So either way, you get that same answer, and it's just kind of cool to know that you have options when you do that. Okay, so let's take a look at a couple others. A slightly more complicated example here, and you notice you can't just like pull this 3 out or do any easy sort of switching up here. So we'll just launch right into the derivative. Pretty easy rule to use. It's going to be 1 over that quantity 6x cubed minus 5x, and then multiplied by that quantity's derivative. And you see I didn't bother to write 1 over because I'm just going to put that derivative right on top. And so the derivative of 6x cubed minus 5x is 18x squared minus 5. And I don't see any way to reduce this fraction, so I am done. And there we go. Pretty nice, right? But of course, things can always be a little harder. They throw more stuff in there, and some trig, as you'll see in these examples, and you just got to be careful and follow the rules that you've been doing all along. This is just one more rule thrown into the mix. So I thought I'd have a variety of examples here, like number 3 here, y equals, and notice it is the quantity ln of sine of x all raised to the 7th. So there's definite chain rule stuff going on here, and with the chain rule, remember, you want to focus on what is that outermost function. That's the derivative you want to deal with first, and that would be the 7th power. So our derivative would be the derivative of something to the 7th is 7 times that same argument, which is ln of sine of x raised to the 6th. Then applying the chain rule, you have to multiply by the derivative of that inner function. So multiplying by the derivative of ln of sine of x, here's where you get to use your new rule. The derivative of ln of sine of x is 1 over sine of x, and multiplied by the derivative of sine of x. There's a double chain rule there. The derivative of sine of x is cosine of x, so I'll just put that right on top. And, there's not a whole lot you could do to this expression, so if you wanted to stop right there, it could be done. Some of you might be noticing, if you were on multiple choice, cosine over sine could be thought of as cotangent of x, so maybe this could be written as 7 cotangent of x times ln of sine of x to the 6th. But either way, pretty good there, right? 2 chain rules, no big deal. Look at number 4. It's pretty much the same kind of stuff. We got sine, we've got ln, we've got an exponent. But remember, when you have this trig expression written this way, that means sine of ln of x is on the inside, and it's all being cubed. So chain rule, y prime equals, taking the derivative of something cubed will be 3 times that something squared, and then multiplying by that thing's derivative, the derivative of sine of ln of x. The derivative of sine of ln of x now, okay, be careful here. The derivative of sine of something is cosine of that same something. So this would be cosine of that ln of x, and then multiplied by that thing's derivative, that inner expression's derivative. And the derivative of ln of x is 1 over x. I'm getting a little scrunched in here, but it's okay if you're following me, if anybody's even listening to this at this point. So, and there we go. If you put that all together, maybe clean it up a little bit, you would have 3 sine squared of ln of x times cosine of ln of x, and it'd be times 1 over x, so maybe you'd see that written as all over x, but I mean, nothing says it's got to be written that way. And there you go. All right, so let's just see one more example here, just so you see this. This is usually, any part of any sort of ln derivative lesson that you might see something like this. And just good to know that if you want, you could start right in and say, okay, I'm going to do y prime of this, and that means I've got to do 1 over this fraction. 1 over that, which would really just make the reciprocal of it. But then you'd have to multiply by the derivative of that whole thing. And the derivative of this fraction would require a quotient rule, where the numerator's got a product rule with a trig function. So could you do it if you just plug away? Absolutely. But you might like to say, maybe I can use a little trickery here, not trickery, but some skills from pre-calc to make my life a little easier. And that would be, remember that any quotient or product on the inside of a log can be broken up using those properties. So I'm going to break this up to, that's the ln of the square root of x cubed, and that's being multiplied by secant of x, so I can break that up to plus ln of secant of x, and it's being divided by this whole quantity, so I can do minus ln of that whole quantity. And that's just, classic log condensing and expanding properties. The only other thing I might do is this first part right here. I might express that with an exponent and pull that out to the front, right? So that's really, x to the 3/2 there, the square root of x cubed. So I could pull that out to the front and say that is really 3/2 ln of x. Ln of secant of x, nothing too cool I can do there. And you might be tempted with this quantity, but 7x squared minus 15x, you can't break up those sum and differences, just products and quotients with logs, so just leave it. But already now you've got a much simpler derivative to do, because these ln's are pretty simple, pretty basic chain rule stuff. So yeah, we haven't done the derivative yet. Don't get too proud of yourself and walk away. But here we go now. These should be pretty easy. The derivative of 3/2 ln of x will be 3/2 times 1 over x, the derivative of ln of x, plus the derivative of ln of secant of x is 1 over secant of x, and then multiplied by that derivative, which would be secant x tan x. And you might already start to see some reducing that could be done there. Those secants are going to cancel. Minus the derivative of ln of 7x squared minus 15x will be 1 over 7x squared minus 15x multiplied by that expression's derivative, which is 14x minus 15. And maybe I should just write a nice, clean final answer here. This would be 3 over 2x plus this just reduced the tangent of x. And this doesn't reduce at all. Nothing I can see there. No common factors can be taken out. So that's a decent final answer for me. If you ever want to make a common denominator and put them all back together, you are welcome to, but that looks good to me. So there we go, kids. I tried to give a variety of examples, easy, hard, and maybe some other things. And, hopefully this made the rule pretty clear on how to use it in a variety of ways. If you have any questions, just reach out. And otherwise, keep calcing on, kids, and we'll see you later.